Yeah? You guys see horizontal asymptote? You want me to show you up there? That'd be good? Okay, is everybody all right there? Sorry? Yeah, that's just because my graphing calculator is an old one. So the graph should really look like this. Should be going down like this forever. And then it should be coming like this. Going down like that. Okay? So then this would be your asymptote at x equals 1. This would be your asymptote at x equals 4. And this is your asymptote at y equals 1. Okay, this is going to be a horizontal line, right? So this graph is going to be going on like this, pretty much flat. Okay, approaching y equals 1, but doesn't quite cross it. I thought this was a math class, not a maintenance class. I have no control over it. No control. Okay, you guys having fun there with math? Yes, Eric? Totally thrilled with math? Nice, I like that. Okay, everybody got asymptotes? Okay. Okay, so what are rat holes? What are rat holes? Okay. So if you wanted to find out the vertical asymptotes on this one here, what would you do? What do you get? X minus 3, x plus 2, right? Yes? So you would see that your VA, your vertical asymptotes are either at 3 or at x equals negative 2. Right? Yeah. Okay, put this in your graphing calculator and see if that's true. And I'll wait for you. What happens? Zara's getting cramps in her fingers. That's why she's not pounding the calculator. She's too cold. Yeah, I know, but why is she driving it? Everybody get something that looks like this? Yes? Erase what? Oh. Yeah? Well, what happened? Oh, Mom, I'm stuck. Oh, no. What happened to x equals negative 2? It's not there. What happened? What happened? Well, go take a look at table. See what's happening at x equals negative 2. Yeah, it does indeed tell you error. So what happened? Yeah. Yeah, I'm telling you, my calculator is old style, so it tends to show a line, but not the new ones will. The new ones won't. Okay, so something happened to this asymptote. Where did it go? It's not there. Nice. Good observation there. It's not there. We got to think about why it's not there. Can I factor the upstairs? Can I factor the upstairs? Do it. Do it. X plus 2, x minus 1. Can these x plus 2's cancel? Okay. That's why it's not there. But instead, there's a hole there. Okay, there's a hole there. So if you want to take a look at your table where you got an error in the table, okay, what that is saying is that if I want to put my graphing calculator up and graph that, at x equals minus 2, I'll just do it on the board here, okay? At x equals minus 2, there's a hole in there on the graph. It's undefined. Okay? It's undefined. Everybody get the idea of a hole? Yeah? Okay. Okay, homework examples. Number 24, page 153, which means you got to open your textbook to page 153, and let's work on that problem then. Okay, number 24. What's it asking you to do? Determine the domains of f and g, simplify f, and find any vertical asymptotes, identify any holes in the graph, and so on. Okay? Does everybody know what I'm doing? Hello? Does everybody know what I'm doing? You have your book open so you know what the instructions are. Vikram, dare you open your book? Brandon, dare you open your book? Anybody need help opening the book? Ilim? You've got great muscles I'm going to be working out today, so. I don't know. We need to find out. Yeah. We need to find out. But let's go through the instructions here, okay? It says determine the domains. Okay? So for f, what's the domain? For f, what's the domain? So for domain, you might want to think of what can x not be. Is there one value that x cannot take for f? It cannot take 3. So it can be anything from minus infinity to 3 union 3 to infinity. What about g? G? Sorry? It can be anything. Right? G can have any value, so it's minus infinity to infinity. Wait, is there any restriction here? Look at it. Why can't x be negative 3? Yeah, it's when the denominator goes to 0, you have problems. Okay? You'd have problems. It says simplify f, so we need to simplify f. Which means we need to factor this. So this becomes x minus 3, x plus 3 over x minus 3. You cancel that. And so your simplified function is the same as what this is. Same as what g is. Okay? Identify any hole. So Subir already told us hole at. Don't just say 3 because it's a point, so you need to give me an x coordinate. Hole at x equals 3. Okay, there's a hole at x equals 3. Now, what is the y value going to be? It's a point, so there's going to be a y value for it. Is it going to be 0? Or is it going to be 6? Well, I know the function is undefined, but you know how when you've got a graph? Hey, let's do this. Why don't you put this in your graphing calculator and see what it looks like? What do you think it should look like? Sorry? Yeah. Yeah, put f of x in the graphing calculator. Oh my God, it looks like a line. Isn't that amazing that it looks like a line? It is a line. And it's a line because when you simplify fx, what do you get? Don't you get x plus 3? Don't you get this guy? Isn't that a line? Okay, so now the question to you is that at somewhere on this graph, there's a hole. What xy value will there be a hole at? 3 what? It's going to be at 3. Sorry? Who's that? Yeah. Does it make sense why it'd be at 3, 6? Because your equation actually turns out to be like this, doesn't it? After you simplify. So if x is 3, then y has got to be 6. So your hole is at 3, 6. What, Nate? Because your simplified equation is this, right? You can see right there. So if you put 3 in there, you get a 6. Okay? So your hole is at 3, 6. Is everybody okay? So everybody all right on this? Thomas, are you here? You're not here. Oh, you're here physically, but mentally you're not here. But you're never here mentally, so. I don't know. Eric's kind of having a flirtation time with Coco at the back there. And I'm done. So, Eric, yes, you may continue flirting. Okay, I'm done. So you guys have 20 minutes worth of homework time. 20 minutes worth of homework.